In this lecture, we're going to look at the first of three macronutrients, the carbohydrates. Macronutrients are those which provide us with energy. And when you study nutrition, energy essentially means calories. The macronutrients that give us calories are carbohydrates, fats, and proteins. 1 gram of carb, you can see here, has 4 calories per gram. A gram of fat has 9 calories, and a gram of protein has 4 calories. Vitamins and minerals are our micronutrients, and they don't provide energy. So if your friend tells you he's taking a B-complex vitamin for energy, it's quite obvious that your friend doesn't understand the concept of energy. There are no calories in vitamins or minerals. Alcohol is another component of some people's diet, and it certainly does yield calories at 7 calories per gram. So an important concept check: 1 gram of carb gives us 4 calories, 1 gram of protein gives us 4 calories, 1 gram of fat gives us 9 calories, and a gram of alcohol gives you 7 calories. Vitamins and minerals do not yield calories or energy. A little bit about carbohydrates as a whole. Carbohydrates should constitute the majority of calories in a well-balanced diet. Some people are surprised to learn that. They've been on a low-carb diet or they think carbs make them fat. But you'll see in a moment that they really should be the majority of where your calories are coming from. Carbohydrates are groups of compounds that are made up of one or more sugar molecules. And we sometimes abbreviate it CHO. So that's short for carbohydrate. I'll also refer to it as carbs. Carbohydrates are made up of carbon, hydrogen, and oxygen. In our food supply, we get carbohydrates from foods like fruits, vegetables, milk, and legumes. Legumes are things like dried peas and beans or lentils. We have simple carbohydrates and complex carbohydrates. Simple carbohydrates include monosaccharides and disaccharides. Mono means one, so that's a carbohydrate made up of a single sugar unit. There are 3 monosaccharides: glucose, galactose, and fructose. Disaccharides are simple sugars made up of 2 sugar units, di meaning 2. And the 3 disaccharides you should know about are maltose, sucrose, and lactose. So we'll jump back one to the monosaccharides, looking a little bit more closely at glucose, galactose, and fructose. The way you can remember glucose is that it's the most abundant of the monosaccharides. It circulates regularly in your blood. So when we study diabetes, we'll look at your blood sugar levels, referring to your blood glucose levels. Galactose is a monosaccharide that doesn't occur freely in nature that often, but it does make up 1/2 of the molecule called milk sugar. Lastly, we have fructose. Fructose is a monosaccharide, and we also refer to that as fruit sugar. So you can think F for fructose, F for fruit sugar. Fructose is made up of half sugar in honey and high fructose corn syrup, and it's used to sweeten many beverages and foods. Your disaccharides again are maltose, sucrose, and lactose. And what's interesting about each of the disaccharides is that they all contain 1 molecule of glucose. The maltose is actually made up of 2 molecules of glucose. Sucrose is made up of glucose plus fructose. We also refer to sucrose as table sugar. So when you hear sucrose and the word sugar, those are used interchangeably. Lactose is made up of 1 molecule of glucose and 1 molecule of galactose. Lactose is what we also refer to as milk sugar. You'll notice, again, each of the 3 disaccharides have one thing in common, and that's 1 molecule of glucose. So maltose, in summary, that's the disaccharide made up of 1 molecule of glucose and another molecule of glucose. It's formed when starch is digested, and it's broken down by salivary amylase. So if you take a cracker and you put it on your tongue, and you don't chew it, you sometimes, or you can always, you should be, if you're making salivary amylase, you feel that cracker start to disintegrate. Okay? And the maltose is the slightly sweet taste that you experience when you hold that cracker on your tongue. Sucrose, again, is table sugar, and in the United States, it's the only sweetener that can be called sugar on labels. So you'll learn that there's lots of other words that describe sweeteners, but if it says sugar on a food label, the manufacturers are referring to sucrose, which is 1 molecule of glucose plus 1 molecule of fructose. And lastly, we have lactose. That's a disaccharide that we call milk sugar. You see a picture of ice cream here. For people that have lactose intolerance, It means that they lack the enzyme required to break down the sugar lactose. Note that each of these sugars end in OSE. That's an indicator, if you see OSE, that we're dealing with the sugar. When you see a related word that ends in ASE, that indicates that it's an enzyme. So you require the enzyme lactase in order to break down the milk sugar, lactose. People that are lactose intolerant don't make enough or don't make any of the enzyme lactase. They eat that sugar lactose, their body can't break it down, they get a whole host of undesirable GI side effects. So our simple carbs are our monosaccharides and our disaccharides. Our complex carbs, there's 3 of them: glycogen, starch, and fiber. And together we refer to the complex carbohydrates as polysaccharides. Poly means many. Glycogen is the storage form of glucose in humans and animals. We are a human, or a type of animal perhaps, and we store glycogen in our liver and in our muscles. So if you weren't to eat for a very long period of time, your body would break down the glycogen in your liver and your muscles to some degree to give you some glucose. Starch is a little bit different in the sense that that's the storage form of glucose in plants. And then fiber is the 3rd type of complex carbohydrate, and that's the indigestible, non-absorbable plant remnant. How many calories per gram does fiber yield? Well, that's kind of a trick question, because we actually don't digest, nor do we get any calories from fiber-containing foods. So these are our complex carbs, or what we also refer to as our polysaccharides. So again, we got glycogen. This is the storage form of glucose in humans and in animals. We've got starch, which is how plants store their glucose, and then we have fiber. You might notice that the glycogen here, it's made up of highly branched chains of glucose. The branching allows for your body to quickly break down the glycogen to give you glucose if you should need it for energy. Starches can have either straight or branched chains. Starchy foods include things like breads, legumes, and starchy vegetables. And then we have fiber. Fiber is made up of either straight or branched chains of monosaccharides. Human enzymes can't break down many of these sugar links. And cellulose is a type of fiber that we find in wheat bran and broccoli. That's a picture that you see here. And cellulose is a fiber that's made up of straight chains of glucose. So I mentioned briefly where we get carb in our diet, but this slide shows you in a little bit more detail. You get carbohydrate from certain dairy foods, from milk and from yogurt, but there's no carbohydrate in cheese because the milk sugar, lactose, has been removed during processing. That's why some people with lactose intolerance can actually tolerate cheese more readily than they can, let's say, yogurt, milk, or ice cream. There's about 15 grams of carb in a medium-sized piece of fruit. And vegetables, while they have carbohydrates, have a little bit less. You see 5 grams of carb in your typical non-starchy vegetable. When we look at diabetes, we'll talk a little bit more about the difference between starchy and non-starchy vegetables. Breads, pastas, rices, tortillas, cereals, these starchy bread foods give us, in about 1 ounce or 1 slice of bread serving, 15 grams of carbohydrate. And generally 15 grams of carbohydrate will come in a serving that gives you about 100 calories. Legumes, the dried peas and beans, they vary, but somewhere between 15 to 20 grams per half a cup of serving of those. There's no carb in meat, there's no carb in oil and fats, but there's lots of carbohydrate in sugars and added sugars. And to put it roughly, a teaspoon of sugar, that's table sugar, sucrose, gives you 4 grams of carbohydrate. How do we know how much carbohydrate we need? Well, carbohydrate should, in a well-balanced diet, except in very rare medical conditions, constitute the majority of your calories. And it should be about 45 to 65% of the total calories that you eat in a day. Now, most people, I would assume, taking this class are somewhere in the 1 to 50 plus year old category. It's pretty much the majority of our population. In the United States, the Institute of Medicine tells us that based on their science, they say all human beings need an absolute minimum of 130 grams of carbohydrate a day. I'll show you in a second that most of us need more than that, but at the bare minimum, you should never be following any sort of diet that takes you below 130 grams of carb. Now, for those of you that have been on a low-carb diet in the past, there's lots of fad diets and nutrition plans out there that are not based in scientific evidence that say, eat well under 130 grams of carb. We know if you eat less than 130 grams of carb a day, you're not going to be getting all the amounts of different important vitamins, minerals, etc. that your body needs. Carbohydrate needs go up when you're pregnant and when you're lactating. One thing that's interesting about carbohydrate needs is that a 1-year-old needs at a minimum 130 grams of carb. A 65-year-old needs at a minimum 130 grams of carb. Most of the differences in nutrition between 1-year-olds and 65-year-olds would be based on their weight. But carbohydrates, it's a static number, 130 grams. And that's why it's important for very little children to have frequent meals and snacks. They can't get all of that carbohydrate in 3 meals like you or I as an adult can. So again, the amount of carb for a 1-year-old is the same as it is for a 50 or a 60-year-old. And those are minimum amounts. Let's do an application. We've got a 23-year-old male. Perhaps he's a student in this class. He's an elite athlete and an endurance runner. Elite athletes, and particularly endurance runners, need more or a greater percentage of calories from carb than the average non-athletic person would. So he met with a dietitian, and the dietitian estimated he needs about 3,500 calories per day in order to meet his needs while he's training. As he's getting closer to his competition date, the dietitian, who specializes in sports nutrition, says, listen, you want to increase your carb to about 70% of your total calories. So I'd like you to take a moment to figure out, knowing a couple of pieces of information, how many grams of carbohydrate per day this athlete needs. And one thing to keep in mind is that every gram of carbohydrate, you get 4 calories per gram. Okay? So take a moment again and figure out how many grams of carb per day should this athlete be eating in order to get 70% of the 3,500 calories from carbohydrate. Here's the solution. Hopefully you got the answer, which is 613 grams of carb. And if you didn't, or if you did, here's how you get there. The question is asking you how many grams of carb a day he needs. 70% of the calories should come from carb as he approaches his performance. 70% of 3,500 is 2,450 calories from carb. Now that's a good piece of information, but the question didn't ask how many calories from carb, it asked how many grams of carb. And the information that we see on food labels is listed in grams of carbohydrate. So if you got 2,450 calories from carb, and you know that every gram of carb has 4 calories, you divide 2,450 by 4 to come up with the answer that's roughly 613 grams of carb. Now you know at a bare minimum he needs 130, but as an elite athlete, he's certainly up in the 600 range, needs a lot more carbohydrate than you would for the bare minimum to sustain life. If you're interested in learning more about carbohydrates, I've got a couple of good links for you here. Medline Plus, which is from the United States, the National Library of Medicine, has a good jumping off page to learn about carbs, as does the Centers for Disease Control. And the Food and Agriculture Organization has some good information for you about the role that carbohydrates play in human nutrition. Lastly, you might want to check out the patient education piece on carbohydrates from the University of California at San Francisco.